Recording in progress now. Okay, guys, I think we should get started. I think they should, other leads should be joining anytime. I'm surprised why they are late today. I'm messaging them in the meanwhile. And before I think maybe Varun wants to take a lead today because he's not feeling well. So Varun, you can go ahead. We are recording as well, so others should be able to catch up as well.
Sure, Ma. Thank you. Hope you guys can hear me clear. I'll just share my screen. Fine. Yep. So today, from Team Salman, I'll be presenting like what processing steps and feature selection technique that I used and the models I used. So there are a few things I did for my pre-processing steps. So for imputation, I used both KNN and simple imputer method. For KNN, I did not use the wind speeds. For simple imputer, I used wind speed. I used for simple imputer because the reason, like, I don't have any strong reason behind it, but the reason that I choose KNN for every feature except for wind speed is just that, like, I felt like the most of the features have complete data, and it is best to impute using KNN. And with the simple imputer, the wind speed data, like, they are missing most of the data in there, like those features. So I thought like it's more relevant to use the simple imputer in that case. That's why I use the KNN and both simple imputer. And in terms of scaling, I use the power transformer, which is basically which uses, like, in the backend, which uses a log function or square and cube root to its in its calculation to provide more normal distribution to the data. So that's why I use the power transformation. And in the next step, so I used two kind of data sets. So in one type of data set, I used imputation and the scaling part only. I did not use the recursive feature. And then in the other part, I used the feature selection technique in another data set, which is recursive feature engineering I used. So I used the voting method with the recursive feature engineering. So what is recursive feature engineering? Recursive feature selection is it is basically it runs multiple times, and each time it runs, it scores the importance of the features and removes the least ranked feature. And the voting method is basically I ran three different models, which you guys can see: XGB and LGBM and decision tree. So what happens is, for all three models, it gives the features, like it selects the features, and then it gives the vote, like as just sums up the vote of all these three models. And the one who has three, like who got selected in all three models, I just chose those features. So here I can see, here we can see that this feature has got two voting, and this one got three. And we can here see that there are features with one voting also, which means that only one of the model selected that feature, and with two means two of the model selected the models. And there are like few features with zero voting, so they got selected in none of the models. So I chose the one who got selected in all three of them. So in the end, I left with 31 features. And moving forward, I used I used three models: XG Boost, cat boosting, and
Excuse me,
random
Varun.
forest. Yep.
Can you go to the previous slide, please?
Yeah, sure.
So here, when you're taking this method, where you're
Yep.
trying to take three of them and then take the best of those,
Mm-hmm.
you got 31, right, features? What if
Yep.
in this type of process, don't you think one disadvantage is that you will land up with very less number of features for further analysis sometimes?
It could be, but we are trying to like reduce the feature as much as possible. Like, we are trying to get the features who are more relevant to our target variable, like who can be more productive in predicting the result. So that's why I use three of them. We can use more, and we can just use one of the model also. So I tried three. Does that answer your question, Sunika?
Yeah, that's okay, but what if there are some features like humanly like a person, not forget the computer, like being a person, you know that some features is something you need, and if what if they remove those features, they don't consider those features, then what will you do?
Yeah, that's a good question. I actually don't know the answer of that.
Why
Oh,
I'm
sorry.
asking is I normally deal with molecular data, human data, so health
Mm-hmm.
data sets, molecular DNA, RNA. There, every feature is an important one. I cannot remove any because human data, right? I'm trying to find the disease and some treatment for that. So if I remove
Yep.
features using these type of things, then I will land up with the removal of those features which could be very important for me, and I'll not find the solution, right? For example, you see, personalized medicine they're doing. I'm
Yep.
trying to find how I can find personalized medicine for a single individual if he's having one cancer. Do you know that if two people having cancer, one person and the other person having the same type of cancer, then the features are not same for both? That's the reason we say cancer is a heterogeneous disease, and we are not able to actually. It's really tough to get to that stage where we get the personalized medicine for each one. Then in this method, how do you think we could optimize?
There is one other way that we can do is like if we like there is one way that we can go with our raw data. We don't remove any feature, and another one is like we can do the manual feature reduction, which is what we have done in our EDA part. So we looked for the correlation. We look for the correlation relation matrix. So we chose the one that made more sense compared to our target variable. So that's another way to do it.
Yes, correct. I feel
Yeah.
that's okay. Fine. Thank you. Thank you.
Yeah. So I use three models: XG boost, cat boosting, and the random forest on both of the data set. So I found that my top model was actually the XG boost, because looking here, sorry. So if I look here, I did not find much of a difference after doing the recursive feature engineering also. Like if we see here, the R square is not there is not much difference in the R square, and like but we can see the difference in the mean absolute error, percentage error. Like the mean absolute percentage error here is like 2.7% only, which is in the case of XG boost is three. Which oh sorry, in the case of the raw data set is just 3.1%. So it did reduce the percentage error in case of while you when we use the feature engineering data set. Other than that, I use the cat boosting. Cat boosting is another ensemble tree model, which uses decision tree and one more I don't remember exactly gradient boosting method in the backend. So what it actually do is like it do exactly the same thing using the same as the decision tree and the gradient boosting, except there is one advantage in the cat boosting is it handles the categorical variable by itself. We don't have to do anything. Like we don't have to one hot encode or label encode. We don't have to do that part. So it deals with the categorical variable by itself. So that's one good part of this. But in terms of performance wise, I did not find using raw data and the recursive feature, I did not find much difference uh, with the cat boost also. Because if you look here at the mean percentage error, it's still like almost the same, 3.28, and here is also again 3.28, and RMSC is also pretty much similar, and R square is almost similar in this case also. So I didn't find cat boosting did there was any impact on the cat boosting model when we did the feature engineering part. Then I used the random forest one. So random forest uh, kind of showed little bit of progress, but again, it did not show any like a large progress in comparing both data set. So these are my uh, top three models that I think after considering multiple models, these are the top three models. I did not do any hyperparameter part. I just did the base model. So that's all I have. Back to you, Imran. Thank you.
Imran, you're muted.
Sorry.
Okay.
Sorry. Any questions? Thanks, Varun. And any questions, anyone? Feel free to ask, guys. You guys just have 2 more chances. Then we are wrapping up with this project.
So Varun, I have a question. Like when I was looking at the table, so cat boosting is taking 0 time for prediction. Is it like it's not taking any time? Is it like that for the prediction?
For some reason, yeah, I did find that while doing prediction, it did not take any time. It just maybe it took much less time than that it could not represent in our number system. So I'm not sure exactly, but while doing prediction, I did not find like it just gave the result.
Okay, and one more question I have regarding
Yeah.
cat boosting itself, like it handles categorical data by itself. So, categorical data we need to provide by creating a different categorical feature or data frame, or just likewise we are handling with other modeling or other modeling.
So you just have to, for cat boosting, you just have to tell the algorithm that these are your categorical variables. You just have to tell the name of the columns and the position of the columns. That's it.
Okay, can you please upload your notebook onto the GitHub, or is
Oh
it
yeah,
all?
sure, I will do that. No, it is not yet, but I will do that.
Okay, thank you.
Yeah. No worries.
Any other questions, anyone?
Varun, I feel maybe you should run again this model cat boost. Just see if you can run again. I feel you will get a better result if you try once more.
Oh sure, I will do that, and I will post that thing like on our channel
Yeah.
also. And yeah,
That'll be good. Thank you.
yeah.
Okay. Well, time to move on. Today.
Sorry,
Yes.
madam. So I'm leaving the meeting now.
Yes. Thanks,
Okay.
Varun. Thanks for
Just want to
presenting. And yeah, he's
Thank
not
you.
feeling well today, so he's gonna leave
Take
early.
care and get well soon.
Take care, Varun.
Thank you. See ya.
Bye-bye. So today, Manisa from Rich's team was supposed to present, but they had some issue. Like she was supposed to present on Azure, but there was some stuff she needed some clarification. I think she and Roy was collaborating, and then Microsoft get back to them a little later. So that's why now they know what they need to do. But I guess now since they got the response later, so now she won't be able to present today. Am I right, Manisa? And she will rather
That's right,
present,
Imran.
right?
Yeah, that's right, Imran. Yeah, but still, Roy will be still presenting.
Yes. I was saying, suggesting referring to your. So yes, so she will present next time. If I'm not mistaken, Nukta, there's a part.
Yes.
Right? Will you be presenting today?
Yes, I can.
Okay, good. We all are very excited for the time series part you want to share. So
Oh, I hope I come up to your expectations.
that's okay, probably. I've given you access, so you should be good.
Okay, perfect. Let me see. Can you see my screen?
Yes. Can
Okay,
you
one
enlarge it,
second.
like on a
Yeah, give me
presentation?
1 second. My daughter has woken up. Let me just get her. 1 second. I'm back. Sorry about that.
No worries.
Slideshow, right? Perfect.
Yes.
So I did time series along with Benita. She worked on the base code for time series without using anything. She just used all of the features and used one hot encoding. So what is time series, first of all? So we talk about time series a lot and what it is, and it is sounds very intimidating. But the thing that time series is based upon is the cyclical nature of data and its correlation with itself. So what happens is, if we talk about cyclical nature, the first thing that comes to mind is the seasons. The seasons, the when we are talking about how the temperatures vary year after year, they are based on the seasonality. In summer, the temperatures are pretty high, and in winter, the temperatures are pretty low. So they every year's temperature is related to itself at the same point in time. So that's what time series refers to. So if we shift the series, so like a sine curve, if we shift it, eventually we will again get a sine curve, right? So that's the kind of seasonality we are talking about. So this picture basically is showing what are the different places where time series plays a role. So for example, in budget analysis, in market analysis, all of these things, they follow a cyclical nature. It's not like it follows a sine curve or cosine curve, but there is some kind of correlation of the target variable with itself. So in those particular scenarios, we use time series. In this case, in our case of climate change, what we found was, if we group together the data by certain variables, then we can see that there are certain buildings that are repeating themselves, and that was the reason behind using time series for this particular use case. So it forecasts, as I was just talking about, forecast the target value based upon a known history of the target value. So it's taking itself into account. It's an autoregressive model. Basically, what that means is that it's just talking about the cyclical nature of the data. So since, as I just said, that since we are talking about when we looked at the grouping of the buildings, we saw that it's probably talking about the same building because it has the same floor area, same elevation, same temperature, and everything was the same in terms of except the target variable. So by those looking at the data, we could assume that the year 1, year 2, and year 3 were presenting the data for the same building. So that's what we have been used. We used. So what I did was tried to combine Salman's method and what Benita had presented. So basically, instead of using year built, I used age, which is another way of looking at year built. I also used the same combination of facility type that he had, and we ended up with 15 categories from the baseline model. And again, I did not use the temperature from the monthly temperatures and average temperatures. Instead, I used the degree days of heating and cooling. I think someone in the group presented that. I don't remember the names, I'm sorry. But we talked about the fact that the heating degree days and cooling degree days are a direct manifestation of what the temperature is, because that's what is more important in our data, is whether the heater or air conditioner is getting turned on or not. And that's what's going to drive how much energy is being consumed by a particular building. So I just provided a few snippets of code here, but we'll go over that. And these are roughly the steps that I have followed. The steps here are just, I just use basic imputation, simple imputation. I didn't get a chance to do KNN, but this is what we did. We basically, first we cleaned up the data example. We computed age, and we dropped the year bill, merged the facility types, deleted the weather columns. So instead we used the heating degree days, and then imputed the missing values, group them by certain parameters, and lag. So this needs to be a little bit more lag the target variable only, because and we have to determine what kind of lag is going to work here. That is another important thing. So we can try lag 1, lag 2, lag 3. Just like if you think about a sine or a cosine, we can lag it by 90 degrees, 180 degrees, 45 degrees, and we can see how the sine wave varies. And at one point in time, if we lag it enough, it's just going to overlay over itself. Used one hot encoding for categorical features. Since we were lagging the features, what happens with lag is then it ends up losing one year of the data, because we are lagging it over each year. So for that reason, we had to delete the year factor, because at that point in time, it no longer had the site UI available to us. And then the traditional method of train and validation split. In this case, I used XGB regressor and used RMSE as the accuracy determining factor. This is the code for group by. Sorry. So basically, I use group by state factor, building class, facility type, floor area, and age. So all of these factors, if they were the same year over year, that means that building is a part of one, that is one building. Over the years, we have been provided the data and sorted the data by using those factors. And this is what, with simple imputation, this is what we got. The RMSE was 34.4, which was worse than what Binita had. Binita did not use any kind of imputation and she was getting an RMSE of 20. So we can use other factors like KNN and stuff like that to go over and see how, if we get a better RMSE and better accuracy from our data. So this is what this is, and then I will share a few articles also that I was referring to read more about time series and how lag works. I will do that in the Slack channel. So basically, I have uploaded this code also. I use the same, the pipeline one simple imputer from what Salman had loaded. So this is just reading the data over here for now. Printing the shape of the data and looking at information, all of the basic stuff that we do. Here it's we are doing calculating the age, so same as what Salman had, and then dropping the year built. So we have only the age of the buildings available to us. And then here the combining of facility types has been done. So I was getting 15 unique facility types based upon the combinations that Salman had determined. And just plotting to looking at it. And then I dropped the weather columns, all of the weather columns, anything related to the temperature, minimum, average, and maximum for all of the months. And the wind speeds and direction of wind speed, elevation, all of that has been dropped. After that, I used a simple imputer to impute these values. And then group them by these columns, like we just talked about. And then here is the one where it's creating the lag for the target variable. So we have created this lag and then shifted the target variable. And then the one hot encoding to convert the categorical variables to numerical variables. After that, the split was done. So, after that, first the year one data was deleted because once you lag that data, you are losing, it's basically putting that value, the target value for the next year's data based upon the grouping. And then you have to delete that because you no longer have the data for target variable available in year factor one because we have lagged it by one. And after that, did a train and test split. And here XGBoost has been used to determine what is the RMSE, what is the score. So RMSE was coming out to be 34.4. And as I said, there are more things that can be done. I didn't get a chance to finish this, but I was trying to use all the other regressors also, like linear regression, lasso, to test that, as well as we can use lagging by different number of years and get to that others and see whether we get a better RMSE. That's all. If you have any questions.
I do have a question. So
Yes.
not all of the not every building has a year one data point. How are you dealing with how are you pulling a lag factor in for whatever the first year that building is present for?
I have not done that yet. So that this was just a basic, just use lag factor to calculate that. So when we will have to look into that as well and figure out how we can maybe use different methods to do that. But I have not looked into that piece yet.
Okay.
That's a very good question.
I have a question.
Yes.
So you are using a lag feature, right? So with that lag feature, are you changing the target value? Is
Yes.
it like change? So you are changing
Not
the target
changing. We are just
Mhm.
lagging it by 1 year.
by 1 year. Okay. So
Yes.
if you are and you are splitting it after using the lag feature, right?
Correct.
So if you split it after that, will that not leak any data? Like you are using the test data for lagging the features, right?
Yes,
So
but we will have
should
to lag it beforehand, right? Otherwise, we will be off by, like, how will we include the lagging in the same validation data also? Right? Is that your question?
yeah, actually, what I'm saying is if you use the test data as well, then if you are getting a new data means how will you lag
Oh, so
that?
in that case, we will have to first combine the data. All of the data we will have to combine. Then we will lag it, and then we will
Mhm.
again split it. We will separate the data, and then we will do a train and test, and then we will just basically follow the same method. So basically, combine the data and lag it, and then separate it again as if you never combined it. And then
Okay.
you will do a test and train validation split, just like you would do for any regular modeling.
Okay. Yeah,
And then
yeah. I understand. If you are getting a lot of data, like in runtime, if you are predicting for a new data, what will we do like for lagging? Do you understand
um,
what my point is?
I think I do understand that, but I don't have I am not an expert in time series to answer that
Okay.
question. I'm
Okay,
still
no
trying to
worries.
learn
But
it.
I have no idea. Just I want to know about it, like how we
Yes,
can do it. Yeah. Okay, no problem. Maybe. Thank you.
sure.
Yeah, it was very good. I like. I did not know anything about this, but it gave a good idea. Thank you.
Thank you. I'll share more documents related to that.
Okay.
Imran, you are on mute again.
Thank you. Thanks, Nukta. Good job today.
Thank
And
you.
any questions, anyone for Nukta at this point? I guess they don't. Yes, feel free to share those articles you are referring to. Komal has
Sure.
shared a file. Would be great if you can post it over there. That will be helpful. Some of the
Okay.
participants are curious, right? And I assume you'll be sharing your PowerPoint as well, or that's from a.
It's already there on the full PowerPoint presentation.
Okay. Oh, thank you. Any other questions, anyone? Otherwise, we will move on here. Okay, I think time to move on. I think Roy should go ahead.
We are also, I think, running out of time. Should we all rejoin?
Yes,
Yeah.
good call. Thank you. Yes, let's do that.
Hey, hello everyone. Are you able to see the screen?
Yes.
Awesome. Thank you, Imran. Thank you everyone for coming. Okay, so today we are going to start with our Team Roy presentation. And this is related to our attempt in doing the use case presented, that is the climate change use case, into Azure machine learning, right? So Azure machine learning is a cloud native product, and that is why we are going to call this cloud native machine learning. Because first of all, it's a product by Microsoft, one of the leading players in the cloud business. And secondly, it has very powerful integrations with all kinds of data capabilities, storage, APIs, and a lot of other softwares and products. So it basically has good integration with all the products in the Microsoft stack, right? Another thing is that the environment used in this kind of processes should be immutable and repeatable. That means that immutability means that once you create the environment for the machine learning, you cannot change it. So since it cannot be changed, you cannot make any mistake, right? And repeatable means you can create a unit that will be repeated in different installations. So today you are deploying in the US East region, tomorrow if you deploy in the Canadian region, then you don't have to do the whole thing again. You just use the same environment. So that is what is repeatable. And then you finally have a low code solution and notebook solution. That means that you can either do like deploy this in a way which is very drag and drop friendly. Anyone can sit and do it. Or you can go the notebooks way, make your model in a notebook and then deploy it into the production. Right? Okay. So let's now look into some of the implementation details. So what are the things that I've used for implementing? We are using Python, we are using Docker, and we could use Kubernetes also, right? We didn't use it here yet, but it is used internally somehow. Also, there is a huge amount of trackability. So whatever you are doing in Azure Machine Learning, it is tracked, it is logged, and all the small things and tags that you want to see for each job you have run will be available inside experiments and jobs, right? There is native support for canary deployment. So what is a canary deployment? A canary deployment is like it's you are updating your traffic that you are sending to the model to a different model. So canary deployments are like blue-green deployments where you are sending part of the input to a blue model and part of the input to a green model. So you have a blue-green in deployment, right? You can even have more than that. So you can have 10 versions. However, the total amount of traffic inside will be 100%, right? So you can divide the traffic into different jobs. It is also serverless and cost friendly because you do not have to maintain any servers, no Python, no Jupyter, no REST API, nothing. You don't have to maintain any servers. It is completely autonomous and is very cost friendly, right? Also, due to the latest environmental sustenance policies and UN Sustainable Development Goals, we can also make this scheduling of the jobs carbon aware. That means wherever it will find that there is a less carbon consumption, then it will go and schedule that job there, right? So we are slowly getting more and more environment friendly, right? Okay, so what is the processing pipeline that I have used? I have used data wrangling, a little bit of data preparation in the beginning. Then we are doing outlier removal. We are also going to do categorical encoding. We tried numerical imputers, KNN imputer and simple imputer. And then we are going to do standard scaling and boosted trees. And then we are going to see how to make a call to the inference, right? What about inference? Because inference, if you're not doing inference, then this whole modeling process is useless, right? You're not creating any value for your client unless you are having proper inference mechanisms. Okay. Okay. So this is we begin with the low code solution where you do not have to write too much code. It's not a no code solution. It's still low code because you do have to write a little bit of code, as you can see on the right. But it's still drag and drop. You can just drag a bunch of modules. You can export data, split the data. Okay. So this pipeline is being run from the energy data, and energy data is the raw data that is provided with this project. So we take the raw data, we execute a bunch of scripts that will create some variables and do some basic preparations, and then split the data for training and testing. Okay. So here what we do is we take one part of it for training, and the other part we can leave it for testing. Now, this is not training and validation split. This is training and test data split. So this data, the algorithm or the process will not look at all. Right? Whatever data the algorithm will look at will be based on the training data. Okay. So this is how the training flow looks like actually. Although the picture may not be very good quality, but you can see that you are first cleaning the data, and before that there is outlier removal stage. You see that the edit metadata means that you are converting the string variables into categorical data. The convert to indicator values means that you are basically creating factors out of that categorical data. So if you can see on the right, you have things like state factor, state 4, state 6. You have building class commercial, building class residential. These are all automatically generated. You don't have to write a single line of code to do this, right? And then you have things like normalized data, which standardizes using the Z score. We
Roy,
apply the yes.
sorry to interrupt. Can you enlarge it?
Unfortunately, this cannot be enlarged at all.
Oh, okay then. No worries. No worries. Okay.
Yeah, I can give better pictures on the reference materials and later on, but for presentation, I this cannot be
Okay,
enlarged.
that's fine.
Okay, so once we split the data, we apply the booster decision tree regression, as you can see, as a model. We can also give other models which are available, like light GBM, linear regression, and all kinds of other models, right? Even maybe deep learning models, but we didn't try any of that. We tried the basic booster decision tree, and we tried the train model module. After the training model, we see that we need to go to the score model, where we are also feeding the split validation split. So here you can see there is another split data, and in one split we are using it for training, the other split we are using it for validation. So we are sending both of these data sets and the model outputs to the score model module. Once it finishes the scoring, like scoring means it will generate outputs for the target variables, right? So it will generate the amount of energy that's going to be used. And then in the evaluate model, you will see what is the model metrics, what is the mean absolute error, what is the RMSE, and all those things, right? So these two combined, the previous flow and this one combined, will give you an entire pipeline that is repeatable across the cloud. Okay, so wherever you are going to log into Azure, you can use this flow to do inference, right? So that's the mechanism of immutable and repeatable. So here you can see the what are the results for one of the models that we ran. It's a boosted decision tree, as we said. And in the final step, in evaluate model, we get the output like this. So you have mean absolute error, root mean square error, relative square error, and finally coefficient of determination. Right. So all these outputs are being generated automatically. You just fill in the blanks and mention what is the target variable and some basic options, and you are going to get a model metrics like this evaluation. Now here you can use multiple models. So if you give two models, it will have two sets of all these things, right? But you can also stack and do ensemble and combine everything that you can do using notebooks. You can do out here, right? Although there are things, a lot of things that you cannot do, but still you can make a basic model and deploy into production. It's very easy. Okay, so now after we create that training process and data preparation, we are going to do a inference. And to do that, we are going to have to click on one of the options. Either you have to do a real-time inference or a batch inference, right? And if you click on if you click on one of these options, you're going to see that all these artifacts below will be automatically generated. For example, MD training one model, train model, normalized data, okay, converting to indicator values, cleaning missing data. All these are transformations. These are not just function calls. These are transformations that use the training data to transform the test data or the validation data. So that thing is important, using the training data information to change your test data, using their mean median mode, using their model coefficients, and using their imputer and all those things, right? So that is the main thing that people sometimes make wrong. They again do the normalization on the test data and try to do that. That's not correct. You have to do all the transformations on the training data. Okay, so here we see that from the low code solution, we can click on one of the pipelines and we can get all these artifacts. And finally, this is the inference flow that is created by Azure to help you with inference in the real life, right? In real world, you're going to have some sort of a service, which is the web service input. You're going to use the previous inference artifacts, like for the transformation. And then after you have used those artifacts, you're going to create the web service output, right? So that web service output will be the final result. That is the prediction of the data that you want. So this is how to do inference using a low code solution. Once you do this, you are just going to call this as a REST API and you can get predictions. But the other way that we tried was to a notebook solution. And in a notebook solution, what you do is you open up notebooks that is available inside the Azure Machine Learning Studio. You create these notebooks, you create your model, you do all the things that you do normally, and what you upload your created model into the system and give it a name. For example, in this case, we used Rich's model, Rich's random forest model, and we just took the pickle file and uploaded it onto the Azure Machine Learning portal. After that, we wrote a script and an environment file. This script will basically just use the model as a global artifact and take that model which we uploaded after all the notebook process. These are entirely custom model. There is no modeling that has been done in the drag and drop mechanism, right? So we use this particular notebooks to call our model. Now, how do we deploy the model? We take that pickle file and we put it onto the models. And from the models, you can see that this is the version 1 of the model. From the models, we have to deploy an endpoint. This endpoint will either, again, as an inference, you either have a real-time endpoint or a batch endpoint. After you do the real-time endpoint or a batch endpoint, what you are going to get is something like this. This screen has all the information required to deploy a model. For example, is the model deployment state succeeded? Yes, so it is succeeded. You can see that the provision state is succeeded. What is the traffic allocation of this model? Meaning, if I have 3 different models in production, how much traffic of the input test data am I sending to each of these models, right? So you can see that version 3, which is the final version, has 100% of the traffic. You can go to update the traffic and say, okay, I want to give 25% to each. You can also see that the first version I deployed actually failed, right? Because of some deployment issues. And those issues you can check from the deployment logs here below. So you can go to the deployment logs and check, okay, what is my issue? Why did it not deploy, right? There are a couple of other important things here. For example, look at the REST endpoint. The REST endpoint is the URL that will be used to get predictions, to call the model, right? That is the REST endpoint. Look at the authentication type. So this is a key authentication type. That means you need an API key to actually call this model. You cannot do it as a public user, right? Also look at the environment. This environment variable, although it looks like garbage, this was one of the main factors and difficulties which I got in deploying this. See, the environment, this is actually a Docker container that is built for you on the fly. And the parent image for the Docker container, you have to give it yourself. You cannot expect Azure to take care of it for you, right? Also, here you see the SKU. The machine that will be used during the inference is a DS2 V2. A DS2 V2 is a 2 GB, is a 2-core 7 GB RAM machine, and that is the resource that you will use to get inferences. How many instances of the deployment are there? There is only one instance, right? So all kinds of important information are available in this particular deployed screen. Okay, now the final two pieces are how do you call the model and how do you refer to the model in your code, and how do you finally call the REST API that you have created, right? In the previous screen, we created a REST API. Look at this. We created a REST endpoint. How do you then refer to this model and how do you call to get a prediction? The first thing is to refer to this model, we need authentication, right? Since these are all sensitive stuff, you could be dealing with a lot of sensitive stuff. You have to do something where it's called a service principal authentication. A service principal authentication is a better and more secure version of a username password. And you can see this is a service principal password I have blacked out because these are sensitive details. But if you give the service principal and the workspace name in line 41, as you can see, I can refer to this model that I have uploaded, right? This is the model that we are deploying onto production for now, which is random forest model. So I can refer to this model after I have authenticated with the machine learning workspace, right? This is from the score.py. Remember, there is only one Python file here to inference, and that is the score.py file. If you can create a score.py file that will authenticate, call the model, and do inference, you are done. You don't need to do anything else, right? And finally, when how to call the model and get a prediction. So you have to create a Python module like this. This is nothing basically calling an HTTP URL, which is this one, line 22. Remember, this is the same URL that is mentioned in the REST API endpoint. The data that is incoming, the data for which you are going to predict, is coming as a JSON. So you dump that JSON and create a dictionary. You create, you mention the URL and the scoring URL. You mention the API key, which I have blacked out, right? So once you mention the URL and the key, and you make a request to this URL using the URL lib.request, you'll get a response, and that response will contain the prediction result, right? So these are the two ways in which you can call the model. One through the drag and drop API, another is through the notebook mechanism, where you can actually write a program to call the model. Yeah, that's it. That's all I have for today. Any questions? Hello?
Any questions, anyone? But I'm curious.
One second. Sorry, I was on mute.
Yeah.
So I wanted to little understand about the score.py, what he was saying. Roy, can you just talk about that once? I missed something there.
Yes. Let me open up a score.py for you. So score.py will have something like this. So it will have some imports. It will have a model. So you just call the model, and then you give it some input, that is data. This data is the incoming data. This is not static. This is incoming data from the service, right? And then you call model.predict. Once you call model.predict on the data, you can just return the result, and this result will be captured in this way. So this result will be captured in this response mechanism, right?
Okay.
So that is the result you are capturing in the response.
So it's somewhat like the source file, right?
Yeah, it's somewhat like the source file.
Yeah, got it. Thank you.
Okay. That's it.
Any questions, anyone? Roy, so those, yes, what you were saying, I know you briefly talked about it. Where you had struggled on this environment thing you were saying, and was the tricky part you were saying.
Yes.
What was it?
I will show you.
Can you elaborate, please?
Yes. See. This will take a minute, but I will show you. That is the main point. If you can figure that out, you take over a lot of problems. Okay, so suppose you have this model, right? You have in these models, I have two models. One is the scikit regression model, that is the test one, and then we have Rich's random forest model. What we do is, and you can see that in the artifact, this is just a pickle file. There is nothing here, right? So what we do is we go to deploy. We deploy it to a real-time endpoint. We say that okay, this is going to be called omdena, right? And then you have authentication mechanism. You have compute type, okay, and then you have which model are we uploading? Okay, this is version 1 of the model. Okay, and here you give the score.py, right? See, look at here, curated environments. What is the environment? What are the libraries that are going to be used for inference, right? Here you can see you have a lot of curated environments, TensorFlow, XGBoost, scikit-learn, and all these things. And these are pretty good. Most of the time, these are pretty useful. However, in our case, I found that none of these two options are actually useful because there is a library called Azure ML Core that is not present in any of these images.
Oh.
Okay. So what do I do? If I go and expand, see this mentions the image name here, right? So what I did was I created a custom container S3 image, and here I actually gave the name of the image that I will show you. Endpoints, climate. I will show you which image I used, environments. And then I went to filter, and in the tags, I used training. This is, if I use a training image, those libraries are there. And then I picked one from here, and I use this Docker, this value as the Docker image pool. Once you do this, you will have all the required libraries. Right? If you do not know this, there is, you cannot get this working. Right? That's the problem. And once you do next, you will have to mention, okay, what machine am I going to use, right? What machine am I going to use?
How
And
would we know which
many
machine to use?
that is dependent on the model size. So if you have a big model, you need a
Like
bigger
let's say
machine.
like ours one, which one is appropriate?
Ours one from 4 GB to 8 GB RAM is enough. So either this 2 cores 4 GB, or you can use the other one that is 2 cores 7 GB.
Okay.
So this is around 0.09 per hour, which translates to around $40 per month. And this is a little more than that. So any of these will be sufficient to deploy our model, right?
So those things to add on. So usually we choose that based on how big our production model is.
Exactly.
Thank you.
And then finally, you have to mention how much of the traffic that you want to allocate. Suppose you have 5 models, and you can send your input data to 5 of these models with 25 or say 20% traffic each, right? So each time you call a model, there is a 20% chance that you will get to one of these URLs. So I just allocated 100%, and once these are fulfilled, you can deploy that model. So how do you test that model? You go to the endpoints, you go to the, suppose scikit-learn endpoint. Here you can see that I tried to, just yesterday we tried to deploy and we had 2 failures for some reason, right? So here it shows all the history of the previous ones, right? Previous things. If we go here and we see, okay, what is the environment? This is the environment. And why did it fail? We go to deployment logs and see, okay, there must be something that is missing in the score.py. See, no module named Azure ML.core. This is the reason that it was failing. This Azure ML.core, for some unknown reason, is not there in any of the inference images. That means you have to use your own image, right? And then once we did that, in the final try, we got it. So here the deployment logs is okay, right? There is no error. And if you want to test the model, we just go here and we click on test. So this is our predicted result, right? If we want to write code to consume the model, you see this is the score API, this is the inference API, this is the primary key, right? And this is sample code that you can use to call your model. I just copied this sample code and pasted it there, right? So Azure already gives you sample code to call your model. You don't have to write a code per se. Just provide the data request and that is enough, right? This data. So this is the sample data here. Similarly, we can go to Rich's model, although that one is not totally, test data is not there. But if I go and create a dictionary here and say, okay, data, my data will be this, right? This one. This is just one. And it will say, oh, it's expecting one. See, these are not documented anywhere. There's very less documentation. So if I give the data, it will give here is a result, right? We have not calibrated the data thing yet, but if you take a row from that inference file, like the test data, and put the normalized values here, then you will definitely get your result. Right? So let me show the score module, no, not the score module, the score.py file that I used. So here is the score.py file. See, this Azure ML.core, if it is not there, you cannot get the model from your workspace. Okay. So this is how what I used to create the authentication, right? And then you call team reaches model, reaches random forest model, and just return do a model.predict and return the result. Right? So this is all you need to do. You upload this code, you mention all the environments and stuff like this, and then you got your service. You got your 100% service, that is 100% allocated.
Well, thanks for that extra information. Sorry about that. Can you suggest us? There are many, actually, majority of the participants are beginners. I'm sure. I'm assuming most of them need more additional help. Can you suggest any course on Coursera or something which can be up to that level, can help them learn
The
this?
problem is, the problem that I saw, all these courses, including Microsoft's own material, those are pretty deprecated, like those are quite obsolete. For example, if I quickly share something here,
yes.
If I go here and notebooks, if I go to know where is this notebooks, there are sample notebooks here. You can see how to use Azure ML, right? Deployment, deploy to cloud. The problem is if you run all this code, you will be stuck forever because all these code are not working.
Oh, really?
Yeah, they've updated their own software and they haven't updated the code.
Yeah, this was the same thing, Imran, where me and Roy were on like 2.5 hours call and we couldn't fix it because it was broken on their end itself.
Oh, okay. Well, that's good that you guys just shared. Okay, that's where the problem is.
Yes.
So I guess for the participant, I guess they keep changing so quickly. So then, how somebody can learn if they are so behind?
Yeah, I will tell you. I will tell you the best way to learn it is to do trial and error. Right. I did 3 hours of trial and error before I could come up with the solution.
But it took you 3 hours, even though that's your forte. You have been doing this work for quite some time. So assuming those who are beginners, like how long it will take them?
They have to go through the Azure ML documentation very nicely. They try to update the documentation. I'll show you one more thing. It's a good way to see if something has updated or not. If you go to Azure ML documentation, you go to the documentation, you go to any of the links, say this one, and look at the date here. See article date. This was updated on 17 July. That means this is the latest document, right? You can go through this. If you open something that is too early, see these keep updating. This is one thing I like about Microsoft documents. See, AWS or AWS documents never have this date. So you don't know whether you are reading a latest document or not. But if you go to Azure documentation, almost always you will find the date and you will know how old that information is, right? So most of these are updated. You will not find any document that is 2021 or 2020. So that way you know whether the new product has been released or not. That's how I found out, right?
And to add on to that, Imran, so Coursera has courses which will tell the basics of everything. But the only way to learn Azure in depth is you have to read the documentation and also practice hands-on. So the Coursera courses just have all the basic stuff.
But as you said, okay, so for basic foundational stuff that participants can cover, do their own. But then same thing, the challenge which you guys had, I would assume people, if they get stuck, they wouldn't know that. Okay, I guess that's where I think Roy just said you have to see if the article is updated and then
Yep.
Okay.
You have to go through the documentation like Google search and document search, and yeah, that's how we go about it.
Okay, good. And then I guess the reason how you guys found out, you guys eventually contacted Microsoft and then they updated you guys, and that's how you realized they haven't updated. One thing I'm curious, Roy, for this Azure thing, once you deploy this model or something, or while you're working on it, if you just sign out, do they still charge you, or you have to literally delete it?
No, you have to delete it. They keep charging you till you delete it.
Okay.
So it's charged hourly basis because the container instance keeps running unless and until you delete it or stop it. Imran. So you have to delete it.
Sometimes if it takes so long, like can take a while, and you don't have time to sit in one go. So I guess you have to delete and start over every time.
Yes.
Do you see what I mean? So okay, so that's what. Okay, maybe I can share. Same thing. I didn't know that part. I was under the impression that once you sign out, you're fine. That's what I did in AWS.
No, you have to stop the container instances, like whatever even for AWS, I guess you have to, like, if you use a container, you have to stop that instance because it will keep charging you.
So I didn't know that. Once I was, well,
you have to stop the instances and delete them. Otherwise, you will keep getting charged. I got charged.
Yes,
I know that for sure.
Seriously. No, they charged me $80. I was like, shoot, I just started learning. And that's when I found out.
They will 100% charge you, right? They are there to make money.
But they should tell, right? Okay, that's how it's gonna be. That you just signing out is not enough. Well, I had to call them and they reverted back. But again, how a beginner would know? So you need to be open about it. Yes, they are there for money. They are adding value, so they are justified. But you need to tell the user where they're gonna charge or how they're gonna.
That's how they make money. They don't tell you so that they can make money by your mistakes.
Seriously,
and for Azure beginners, what they have done is they give you like $200 credit for first year, Imran. I think for first month they give you $200 credit to learn, so you can utilize everything up to $200. After which it will get charged only for beginners, like only for the beginners.
They give you $200 first year.
Yeah.
It's
only for the beginners and who is opening a new account to learn.
But does those
That's also
go ahead, Sunita.
That's also not enough, actually. When I was doing masters and we had this cloud computing class, they tried with AWS, and these things happen, right? However proficient you are, you cannot control some things, and so the university gave that option. You can go ahead, $200 you have and all that, but everyone was like out of it and they were getting charged, and ultimately the university stopped that and they came down to, let's only learn the concepts, let's not do anything. I basically feel that it's best to work in an office environment, like work environment, use these things. That's where you get to learn as you do. Otherwise it's tough. Really tough.
Well, to get into a job, you need to have some expertise before they take you, right? That's a little
you need to so that brings me, if you don't mind, I can little bit explain about recent interviews that I've gone through.
Yes, I had in my agenda for you to share the participants. Can you go ahead?
Is this the right time?
Well, let's wrap Roy, and then I have
yeah, sure.
I had one quick comment talking about the free $200 through Azure, and like AWS has a very similar thing. It is not for the first year. It is $200 to use in the first 30 days.
Yeah,
when
first
your
month.
account opens. Yeah. So it's not the first year, and you're never, like, if you're just learning, you're probably never going to use $200 in your first month. And then you'll get into your second month and you'll start using it and you'll get charged. So just be aware of like leaving services like hanging, thinking that you have $200 in your first year. It's not the year. It's 30 days from when you open the account.
Right.
So how was it like? I'm deliberately sharing that what happened. Like when I signed up for this account, when you take Coursera's advanced specialization courses, they give you 2 hours. You just finish the lab, they give you credit. So that's how you do it. When you create your own account in AWS, so I was playing around with our model, but then same thing, like after 2-3 days, I didn't know. I was just signing out and I thought I'm good to go. But then they billed $70. But then I realized that to whatever the free tier thing, whatever stuff you were saying that they give you some credits, I think they just goes by very fast.
Yes.
So it's nothing. I mean, what is it like? I feel like what are you gonna learn with that?
That's the catch here, Imran, because they don't want you to use up all the $200. That's why they give you 30 days.
No, but it was just open for 3 days, and I don't know. I don't know what happened. I said, okay, let's check the billing part, and there was $70. I was like, really already?
Actually, in
Tried to
AWS,
call them.
you have a option to keep your billing cycle alert, which will come on your phone. Like once that thing is reached, that is like a reminder for you to go and stop your instance or something. So there is a billing cycle alert. You can keep it like an alarm kind of thing.
Yeah, that's something I found out later. And then of course they reverse by charges, but I'm sure many beginners may encounter the same thing, like Salman also encountered, right? He was saying something like that.
Yep, means I was trying on my own, watching YouTube videos and everything, and I did not close the instance, and I got charged $75, I think. And then what happened is I was taking a boot camp, and during the boot camp we had an AWS class. Means everybody did the class, they did not close the instance. And after one day, everybody starting saying I got charged this, that, or everything, and I told them that you need to go and close it, otherwise you're going to keep getting charged. So that is something which I experienced, and a lot of people in the bootcamp experience. Yes.
Yes.
So then, what's the solution? I guess you just have. Sorry, go ahead.
Delete means by deleting the instance. It made it stop, because by just stopping the instance did not work. I had to delete them. Yeah.
Okay, what if you cannot in one sitting you can finish? So then how would you approach that?
You will get charged.
That sounds, but I guess that's how it is. Okay, now I know. Now we all know. Okay.
Yes.
1 minute remaining. So if we are starting again, we need to rejoin probably.
Okay, so we need 15 minutes more, so let's rejoin and then we're gonna wrap up. Okay. Okay, well, enough discussion on Azure, although it was worthwhile, I think. I have a AWS presentation as well, and I was today, like, if you asked me 2 days ago, I was expecting there will be 2 more participants. So I was hoping, I was under the impression we won't have time at all. So that presentation will also take some time, but there's a few things in agenda I have to finish it as well, because I keep 1 hour, 30 minutes max on Sunday, because we need to keep a work-life balance too. So let me discuss those things. I don't know, AWS, all the presentations ready from mine, but I don't know if we can finish that in 15 minutes.
Imran, I think I have to present too, but if you don't have time, I'm okay.
No, but here's the thing. We don't want like quick and dirty as well, right? We want to be people to absorb it as well, right?
Yeah.
Today is Sunday, right? We have some minutes here.
Sunday.
Yeah, but there are a few things in the agenda also which are also important to finish before we wrap up. So it's already 10:15 here, like 15 minutes left.
So you want me present it on, sorry, Imran, you want to present it on Wednesday or Sunday?
So here's the thing, based on, I noticed now we have to change our priorities now. I know Salman wanted to present, but he got sick, so he's going to present. He asked for to present later. Manessa is in the same boat as well. Team 4 is also in the same boat. They are supposed to present on Wednesday. So 3 on that side. You are 4th. And this AWS I made, if people are interested, I could give them a high level one, so it will help them as well to give exposure. So that will be 5. But then it means there are many presentations. So what I'm thinking, Wednesday we are supposed to have an official last meeting. I really didn't want to go beyond that point, but since we have that many presenters, maybe we can have one extra meeting and that's it. We could have finished.
If you want, I can present it today in short, because Roy already explained most of the stuff.
Okay, then go ahead. Since yours is Azure related, you go ahead then.
Exactly.
Yes, that will be helpful.
For me, it would be maybe 55 or 10 minutes. So.
Okay.
Can I give me the?
I did.
Can share the screen. Yeah, make me co-host. Okay. So we already know about the main cloud computing provider, AWS. Oracle, Azure, Google Cloud, and Alibaba. That is the main one. I'm going to talk about Azure today. The reason we're using cloud computing is flexibility, scalability. You can use it everywhere. That's important things. For example, for me, I'm working on different projects of computer vision and using regression analysis and kind of working with the numerical data. And based on that, I choose my compute target. I'm using the GPU for my computer vision project and the CPU for the class regression project. So you can use, based on your project, what kind of service or what kind of compute target you want. It's all the region you use. I'm running my computer vision in 3 different regions now. One in West US, because I'm in Nevada, Middle US, Eastern US. Also, I can use the Europe too. So you can use the GPU in Europe, send Azure Center, and run my all models. This is a list of all the service Azure has that I'm going to use in the analytic part, machine learning service. I talked about Azure AutoML last time. Also, I'm going to show you one result. Also, Roy talked about Azure Designer. I'm going to show you some result from Azure Designer 2. The reason my screen is small because I want to back and forth between go to Azure and to my PowerPoint. That's fine.
That's okay. Mm-hmm.
Okay, for Azure AutoML, so you give your the data sets, the CSV file, there's a tabular data. Then you can tell, I want to go through all the regression modeling, or depend on your data set you have, is classification times 3, actually Azure added computer vision and NLP projects, so you can even automate or use AutoML for your NLP, your computer vision, object detection, segmentation project too, and you get the result. Then do featureization and give your the compute target or what kind of virtual machine you want to use. Then your automated machine learning service go through all the modeling and give you the result. In my case, these are the right side you see here is about 1, 3, 4, 5, 6, 7, 8, 9, about 12 model. AutoML go through all these 12 model algorithm and tell me which one is the best model you can use in case of our climate raw data set. I created 3 models for climate raw data, simple input and KNN input, and for my it seems for my raw data the variation explanation is highest. Then I said again voting ensemble. For a case of Spearman correlation is highest. So voting ensemble explain the highest variability in my model. Also, AutoML give you the, here in this case, about 12 most important variable that explain my model. So in this case, for using AutoML, give you, okay, the voting ensemble is the best algorithm to use. Also, these are the most important feature in your model. Then you can go and run the voting ensemble. These are some of the metrics using AutoML in voting ensemble. As you see, you can have mean absolute error, mean absolute percentage, R2 score, Spearman correlation, and normalized mean absolute. Okay, now I want to go to Azure Designer. Roy talked about Azure Designer. This is too small, so I will go to Azure Designer. This is Azure Designer. Just want to show you the workspace that Roy used. So you can put new pipeline, It's drag and drop. It's so easy to use. And you can run about maybe 10 models at the same time. A little slow because you're sharing the screen. Okay, I already made it. Let me just go here, just show you some example of here, for example. Okay. This is just drag and drop, okay? So here, let me, for example, in case of our data, you can search here is raw. Yeah, Automa raw data, drag it here. You can remove this kind of example data set, automobile price, delete, then connect my raw data here. Connect. So this is my data set now. To select the column, that's important. You have to select. I don't want to go through all the detail because of time. So then clean the missing data. Then split data. Use these two algorithms. Here a little name are different. This kind of boosted gradient forest, and here random forest. Then based on this algorithm, train my model, score it, and evaluate my model. Here I can show the model I created. Let me this is here. Here. Okay. So, climate raw data designer. Okay, this is my model. Okay, so this is my raw data. I'll select the column in data set I want to use. Then clean missing data. I'll remove duplicate data. For example, in this case, just click key column selection filter. So all the column, for all the column, remove the duplicate data. Then I normalize data. I normalize the data based on the z-score for all the data except target column. They I mentioned do the field exactly kind of feature engineering thing or feature selection. Click, go through all the data set and select the 12 most important feature. Then use this 12 feature for the modeling part. So they do the KNN part, they do the PCA part, everything is automated here. Then for this filter-based feature selection, do the split data. The split data for here, because our data set is large, I use just 90% of data for training and 10% for test data. Then make it smaller. Let's see. I use two models. Boosting model in the right, random forest in the left. Go to train my model, score it, and evaluate it. In green mean here is went through all the steps I've done. Go to evaluate model, right click, preview data, evaluate result. The top one is for random forest, if I'm correct. Yes, I think. And the bottom number are for boosting algorithm. And this is our result. It seems the boosting algorithm has a better result for mean absolute error. We can get root, mean square error, relative square error, relative absolute, and coefficient determination. So this is best way. Even you can add. I actually used the neural network. Neural network didn't give me the good result. You can use more algorithm here, for example. If you actually here is the model. So you can use, I think we have about 5 or 6 regression or kind of using the numerical modeling regression algorithm in the Azure you can use in the same time. At the end, you can give about, for each algorithm, give you some number, and you can choose what is the best algorithm I can use. Also, the rows show you how you can deploy the model. After you're done with the designer or AutoML, you can just deploy your model. That's the easy thing for using Azure. Also, the notebook is here. At right click, you can also judge the coding part, create a notebook, and actually here, this terminal, just create a notebook and just write your code here and then create a model using Python code. So AutoML, Notebook, and Azure Designer are the best approach to create a machine learning model. Also, regarding the courses, I agree documentation is the best, but Coursera has a good course. Is a DP100 course, because DP100 certification in Azure is for having good skill in data science. It's a 4-5 course, go through all the machine learning thing, how to deploy the model, how you automate the model, how you use the pipeline, how you use the ML flow. So it's a great help. So DP100. Another a good course is Azure Machine Learning Engineer in Udacity. That is also a great course.
Is that
I'm
paid?
done. Yeah, Imran. If any question?
Is
I tried to
that
be
a paid-
fast, sorry.
Is it a paid course?
What? Oh,
You
yes,
would-
it's a paid course. I got a
Udacity.
scholarship for that one. I was lucky.
Oh, okay. Nice.
Yeah.
Do you mind sharing those links and those
Sure.
that file
I will
which?
do it. Definitely, yes.
Thank you.
But they are
Thank-
great courses. To use it to show you how to deploy the model and how to use the different approach in machine learning, especially DP100. It was helped me a lot. I just passed the DP100 exam last month. It helped me so much.
Really? DP100, and you took that course or
Yes,
Coursera?
I just used the DP100 Coursera course. It's a 5 course, it's a specialization. But it's very helpful. It helps you a lot if you want to be a specialist in Azure.
Well, thanks for sharing your experience. Any questions, anyone? It's getting late now. Okay. If not, here's the thing, your guys' call. I made a AWS PowerPoint, and if you guys want to stay, I can do it now. If not, then we have to push things up because I have left with no choice. I was under the impression there would be 2 more participants, so I knew my number will not come most likely. So your guys' call. It's Sunday, so you tell me. Otherwise, I can try finishing in 10 minutes.
No, I'm good. Let's do it.
Okay, let's do it. Yeah, in weekdays it gets more tough anyways. So it's gonna be a bit quick, but yes. Okay. Can you guys see my screen?
Yeah.
Okay, good. Before I start, I would like to emphasize here that, of course, I talked to some of you personally as well. I deliberately kept it to very, very foundational level because after talking to you guys 2 weeks ago or a week ago, you guys were saying none of you know most about AWS. So I wanted to keep very foundational level. Few of the things in my own personal experience, like if I have to present this same thing on corporate level, my approach would have been very different. In this one, but deliberately my approach was different. In fact, I took some slides from my personal notes. So ideas, so then beginners, they sometimes when you speak things, it doesn't stay in their heads. I was thinking maybe to deliberately some of my comments in these slides, so at least once they refer back, assuming after this presentation, it will really save their time, and hopefully it will start to make sense to them better. So it was a deliberate approach. Okay, I'm going to be a bit quick here. Today I'm be covering AWS ML workflow. Okay. Well, as we know by now, this whole machine learning pipeline involves data exploration or data pre-processing, bias detection, feature engineering. So this is kind of our part one for the most part. And this is what we have been doing in part two of the in this project. As far as AWS is concerned, they have their own, what should I say, tools they use, and that has their own particular name, like AWS X3, AWS Athena, AWS Glue. Each have their own function. AWS Wrangler, Data Wrangler, SageMaker, Clarify, Autopilot, all have their own functionality. So as an outsider, those who have no idea, they wouldn't be able to understand, or at least could understand how to approach a problem until they know what each of these things does. So since our idea is to hopefully go towards understand AWS sites, I was hoping to first tell their functionality and show some related cases as well, and how we can handle with our data. So this is what I'm trying to say. When data ingestion and analyze, you know which tools to pick. Let's say for data ingest and analyze, for data exploration from that, we will be using it's AWS S3, AWS Athena, AWS Glue will be required. And I'll explain a little bit about how and what each of that means or how it works. First, data exploration or data ingestion exploration. So what happens, let's say, you can always consult back to PowerPoint later. In our case, there's lots of raw data, right? It can be structured relational data, semi-structured relational data, unstructured data, or like images data, CSV files, movie data, any kind of data. So in AWS, the way it works, you can just directly use whatever data you have, and then you have to put that into S3, which I just mentioned earlier. You have to put in S3 bucket. So that's how it is. Like whatever the data you have, I also encourage, once you are done with this presentation, I'm going to share this PowerPoint. Make sure you read these comments also, so then it will make more sense. I deliberately left it over there. These are from the lectures. So let's say if you have a CSV file or something, you have to, in our case, there is CSV file. So you have to put that transport into S3 bucket. It's a one-liner thing, but that's how it works. Like it's a S3 called simple storage service. You have to just put your data into that S3 bucket before the system can recognize it. And then, as I said earlier, you will also need AWS Data Wrangler functionality. Basically what it does, it just connects Panda's data frame, which we already covered in our in the whole this project. And then there's a AWS, it connects the Panda data services frames with AWS data services. As I said, basically it helps to retrieve data directly from S3 bucket. So once we have the raw data, we put into S3 bucket. Then after that, we need Data Wrangler to utilize that data. So that's why we have to import that library. And as I said here, load unload data from data lakes. So S3, when I said earlier, that's a data lake in which you put your raw data. That's how they say it in AWS. And feel free to stop me if anything doesn't make sense here. I'm deliberately keeping very high level here. Then it comes a thing called AWS Glue, which I mentioned in slide 2, I believe. AWS is needed also in this data ingestion analyze phase. What AWS Glue does, it basically just creates reference to the data. Basically, whatever the S3 data you have in S3, it creates a mapping with that. It's just what's the term they use? It's like this data catalog service used to just register or catalog the data in S3. So just kind of register the data, whatever you have in S3. And that also has this particular format you have to give that when, as far as coding is concerned. So it just helps you register your data. And then there's a thing called AWS Athena, which I also covered in slide 3, which is needed. AWS Athena is mostly like SQL queries. So once you put your raw data, once you put in S3 bucket, then if you want to customize based on your need, you use AWS Athena that helps you basically customize your query. Let's say if you have a data with bunch of product reviews, and if you want to you just want care for the product category from that. So I mean, for that you need to in order to work with AWS Athena, you need to understand SQL queries too. That I'm not sure how many of you know that, but yes, it's basically require an understanding of SQL language as well. So at least you can customize your an entire data set of what if you want only subset of data for your custom needs, for your required needs, you need SQL queries to customize that data. I highly recommend, feel free to please read these comments also. These are very relevant. Then after that, for data ingestion exploration, you also need bias detection. We covered that in our part 1 already. I'll just briefly touch base on how AWS handles that. And I'll also cover briefly on a feature engineering part as well, very high level, deliberately. To detect bias, statistical bias in the data, there's a AWS command tool called, again, Data Wrangler is used. And basically in this case, Data Wrangler provides you with capability to connect various data sets, which I just mentioned earlier. And it also helps you to generate statistical bias reports, as well as, yes, just focus on statistical bias reports as well. And what Data Wrangler is mostly for a subset of data. So let's say if you have a data set of like a very big data set, you just use a subset of data, and it's for a smaller data set. I'm going to cover what I mean exactly in 2 slides later. And for data clarify, it's kind of same thing. It helps you to find a statistical bias in your data set and generates the report, like whether it's AWS Clarify basically we use when we have a very big data set and we want to use all data all together to find a statistical bias and generate bias reports on that. But as compared to Data Wrangler, it's used for a subset of data from the entire data set. So there's a good comparison. This slide will tell you, break it down as well, what it means. There are 2 approaches AWS use for statistical biases. One is AWS Data Wrangler. Another is AWS Amazon SageMaker Clarify. Wrangler is only using a subset of the total data to detect bias in the data set. And AWS Clarify, SageMaker Clarify is for a bigger, large data set and to find a bias at scale. So that's a distinction between the 2. Again, it's a more high level. There are lots of coding as well needed, but I'm just keeping it high level so you can understand a bigger picture here. For feature engineering, you can also use AWS Data Wrangler, and they have a thing called SHAP they uses. I'm forgetting the full form of that, and they uses that to find the most important features in your data set and get rid of the not much important ones. Then comes a train and tune data set. I'm going to speed things up. We're running out of time. In that one, either you can do automated ML, and for automated ML, you can use Amazon SageMaker autopilot feature. I'm going to explain what that means. What is automated ML? Well, that helps to reduce time to launch your products in market, and also it's for auto ML features mostly for those who have a low ML background or non-data scientists, maybe very beginners in this level. They should be playing around with that tool. I'm going to share the links later in my slides, and just for help to get a quick and dirty way to see how what models could be applied on your data and how it could be hyperparameterized, and how the quick and dirty way to analyze the data. For auto ML with Amazon SageMaker Autopilot, basically what it does, it covers all 3 aspects. Amazon SageMaker Autopilot feature, which I said it here, it covers all three features: data ingestion, data transformation, and train and tune data. It all is covered here by Amazon SageMaker Autopilot. You use that and it will take care of all three of them automatically for you, automatically generate reports, 3D coding and all that stuff in Azure, which Roy was saying. I believe it's AutoML. It's the same thing here. It's they call Autopilot, AWS SageMaker Autopilot. So the whole, as far as whole architecture is concerned, it's a high level overview, of course. You put your raw data, whatever data you have, you put an S3 bucket. There's one liner thing. I'm going to share the code so you know, understand what I mean. You just give the reference of the data. It creates S3 bucket, and then it goes through that ingestion analysis phase, which SageMaker Autopilot takes care. And then after that, it analyze the data, do the statistics on that, like as the bias and all that stuff, as statistical bias and all that stuff. It identifies the whatever your data from in which category of the ML problem your data applies. So like in this case, it will decide whether it tells whether it's a regression problem or categorical problem or different kind of problem. So in this case, it's a regression problem, and then it picks the appropriate algorithm for that and defines the candidate pipeline, do the feature engineering as well. That creates all different reports for you, so at least you can analyze it as well. And then it gives you file notebook as well. In feature engineering and for prepare and transferring and transformation from a feature engineering, SageMaker Autopilot automatically takes care of the transformation of the data. Pretty much what we did in part one, it just basically automatically does it for you as well. And then in train and tuning side, again, it takes care of the hyperparameter optimization. It picks up the top few models and it tells you these as the different evaluation. Let's say top 10 models have these evaluation results, and it tells you which one you want to deploy, and you can just pick and choose from that. And then in the end, it just gives you pick some models for you, metrics, models, and notebooks for you in the end, and then that just pops out the final result. And what am I missing here, I guess? And then these are some of the links. Only this link, I will open it for you. There are tons of links online. These are some of the ones I found when I was working with that, or at least these are good. I think can be a good starter for the beginners. One of them, I think, is this one. Don't worry about this $10 thing part. You just create an AWS account, create a free tier account, and then they give you a few hundred credit. Once you create that, basically, it's very easy to follow this particular steps for beginners. I thought it's a good starter. Once you make AWS account, it tells you click on AWS SageMaker Studio. You go over there, basically pretty much set a default how they tell you here, create S3 bucket, and then you create submit. So your S3 bucket is created. Afterwards, you either you pick a data from their data set. In our case, you just upload there's an upload feature. You just upload our CSV file and then give a link here, the way they mentioned of your data set. And then like here, they're mentioning about it. And then you upload that URL into your system, AWS. And then it tells you need to create AWS SageMaker Autopilot experiment. In experiment phase, you know how I was saying you just define your experiment autopilot tutorial, maybe you can say testing something and give any name of your experiment, give the S3 URL. So as I said, once you put your raw data into S3 bucket, you get a S3 URL, which it will generate itself automatically. So you just have to copy from the top part, paste it here, define your target attribute. In this case, it's site EUI. In our case, it will give you on drag and drop on this thing. You just have to select it, that's all. And then you give the output location of that as well, of your data. That's also pretty much the same thing in your case. When you create an AWS account, it gives you account number, you just posted that. It will save as is, and then you just create experiment, and then it will automatically start doing analyzing, feature engineering, model tuning as well for you. And then in the end, it will tell you which models are the best. And then you click on model deploy, whichever appears on top, whichever has the good results, you deploy it. And then pretty much it's going to do the predictions for you. And then you just clean up your data, make sure you clean the notebooks after that. Again, this presentation was very high level, only for beginners. They can just use this link and just do quick and dirty where we have our data, and just to play around, they can just do step by step. It's very basic. Do that. Although I was really interested to give whole end-to-end demonstration with our data, but of course there's so many participants, I don't know how to squeeze that whole presentation. It will take at least 45 minutes, only me presenting that. So, but I thought rather than presenting nothing, I thought just to give you guys whole high level how it works in AWS and how what different terms means in the AWS environment. So hopefully to open minds of the beginners. Any questions here? Sorry, it was like very quick. I had to rush through.
No, this is good. We've got to know about the AWS ecosystem and the tools available, mechanisms. This is pretty good. Thank you.
I mean, there's a lot more than that. So I was feeling bad because I'm still keeping it so high level, and there's so much in depth I can share. But again, time is short. Otherwise, if you guys want, maybe I can organize one session later on. But I guess, but I hope it helped you guys. I'm still going to share this PowerPoint. I still encourage to read the comments. I deliberately left it over there because for beginners, rather than they watch hours of videos, at least they should watch what those comment means. At least they know what each tool means and what it does. So that should help. Okay, guys, any questions? Otherwise, we are wrapping in 5 minutes. I'm going to share 2 quicks and then we are done here. Yes. Okay, guys, very quick. Okay, if you have any questions, please post on Slack or message me privately as well. Okay, Komal. Is Komal here right now?
Yep.
Yes,
Yeah.
Komal. Can you quickly share with the participants on what LinkedIn stuff we are talking about? Like briefly tell them what it means and what you are trying to accomplish here.
Yeah, so like I mentioned, for the duration of 1 to 2 months, we have worked with all the talented people around. So we want to make more connections and grow our connections and give recommendations and endorsement on these skills that we have demonstrated or we have acquired during this course of time. So we have made an Excel, so you can put in your Excel if you want to add people in your network and endorse each other on these skills, give recommendations. It's going to help us to grow our network and maybe seen more by the recruitments and other parties. So please feel free to add your LinkedIn profiles so that other can connect with you and endorse each other.
Basically, the idea is, although we are here at one team and we are all over the globe, so we all have planned to go to pursue a career in ML or data science side. So we are not competing against each other. We are just all our well wishers with each other. So, and the sense, I personally think those who stayed and survived till end of this part 2 from part 1, I think most of them have the good knowledge because we cover different kind of models. They're all end to end. So people have good understanding, at least a decent level, so they can deserve some endorsements. So maybe feel free to come up with creative ideas. So at least we can all at least endorse each other on LinkedIn. So then it will really help us in the end of the day to get the most of this experience. So if you have any good ideas to execute that, help us out because we just have an idea. You can help it materialize.
So you have mentioned some skills that we can get endorsed for, but if you find there are additional ones, please feel free to use them.
Yes, Roshni.
I have one question regarding the coupon code for data quiz. Actually, I checked with all other participants who have received the certification for phase 1. They all have got the coupon code, but I haven't received it. So
you can message me privately for that, and I'll take care of that. That's
yeah,
irrelevant to other participants, but yes, I'll take care of that. You message me.
Okay.
Sure. No worries. Any other suggestions if somebody have as far as LinkedIn is concerned, or how we can make it happen so at least in one sitting people can endorse each other or something like that? Come up with an idea. If you have anything, tell right now. Otherwise, I don't know. That's the best we can think of to help you guys out.
I have one suggestion. Like, can we keep last 10 minutes for job hunting and how we are approaching? I mean, so there are so many people who are transitioning into this field new. So how they are approaching the job interviews, how they are preparing for it.
So if you guys want, once this officially ends, because since I also covered AWS, so it means Wednesday should be our last meeting officially. If you guys want, as far as LinkedIn and this job tip sharing and endorsing each other on LinkedIn, maybe we can have, well, that will be in addition to our Omdina thing, like maybe next weekend only for half an hour, maybe everybody just come and endorse each other, maybe share their tips, job searching or whatever the things they want to share. That will be optional thing, but that will be helpful. If you guys want, we can do that only for half an hour next weekend.
The best way to endorse is that the skills that you want endorse, top 3 to 5 skills, rearrange them, reorder them, and put them on the top. So it's easier for everybody to go just and endorse that. Otherwise, I'm sure everybody has like 30 to 50 skills written.
No, we don't have time. Top 5. That's
Yes.
it.
So that's what I'm saying.
Yes.
That top 3 to 5 skills, just put them on the top on your profile so that people go and just endorse those quickly.
Okay, that's a good idea, actually. Yes, people just go on LinkedIn or on their Excel and then know this person wants this and just boom, boom, boom.
No. On LinkedIn itself, you can rearrange your skills so that you don't have to go looking for those. So the top 3 skills that you like, you can go into the settings and change those. And then the person who is going to endorse it, they can just go on your profile, look at the top 3 skills that is already appearing on the top of the list and endorse those directly.
How do we make sure that everybody does endorsement?
Oh, everybody does. Well, for that we can use the tracking sheet that, okay, this person I have already endorsed you, like that.
Okay, yes, that's a good idea.
What if I don't like anyone like Nukta and don't want to endorse her?
Don't endorse me. Then don't endorse me.
Just kidding.
Okay, a little bit of creativity needed if you guys want to get some value out of it. It's just an idea we propose. If you guys think something, you can make it come up with an idea so then we can actually materialize it, share it. Otherwise, well, it's just an idea. That's all. We are running out of time, so I have to be quick here now. Maybe you can feel free to post on Slack if you guys have come up to some idea. And last thing, Sunita, if you can share your experience with everybody, and we are wrapping up now after that.
Yeah, I'll be quick. So I applied for different positions. One with my background, I have research background, I have teaching background, I have some data science and some machine learning like bioinformatics, right? So I applied for all of this. We might run short. We might have to start again. I don't know. So basically, the first round is a screening round where the recruiter will talk to you, next the hiring manager, and then the team. This is how it goes. So when the recruiter talks to you, he will ask you about all the skills that they are looking for. Do you have? Do you have? Do you have? And if I think more.
Go ahead, Sunita.
Yeah, so the first round goes that I think the first screening round is very, very important because the recruiter is going to forward you to the hiring manager only if he makes sense of what you know. So if he knows, okay, Sunita is a good candidate because she has these, because he doesn't have any sense of what the technical skills they're looking for, the company is looking for. It's only listed down on a paper and he is going to ask you, okay, do you need a H1B? Are you an OPT? Are you eligible to work in the US? Do you know AWS? Do you know Python? Do you know SQL? Blah blah. These all things. So if first thing is that is what your resume should be. So if you have put on your resume what all things you want to do, like if you are going for BI analytics, then you should know SQL, you should know BI tools and Excel. If you're going for data science, you should know end to end. Have you done an end to end project in data science? uh, Again, you have all those data science skills, like cloud is one, SQL is also one, Python is one, R, and all of these things. And when you go for ML, of course you should know whether you know the deployment stuff, you know the engineering stuff or not, these things. So I have applied for an ML. I've applied for, of course I have bioinformatics, so I applied for bioinformatics also, data science and data analytics, to see where I fit in, because my resume was made for all of these things together. So how do I do that? I have worked as a bioinformatics. Bioinformatics is a part of data science. So it is bioinformatics data scientist is the thing that was told to me. I was in the previous position. But when as a data scientist, you are doing your analysis, uh, you are building those models in whatever language. But when you talk to the stakeholders, again, you need to know those BI tools. That's how I put BI tools. Excel, of course, uh, is not a skill anymore, it's a necessity. So you put in Excel, you put in those BI tools, any of the BI tools. Now they are all competitive, mostly Tableau and Power BI. So you have to see what that company is asking for, and you put that, and maybe brush up on a one crash course before the when you're submitting the resume. If you're thinking that you'll be called, if you want to be called, you just brush up on that, whatever you put on the resume. It's not possible that you know Power BI and Tableau together, or quick or looker, all of these things, but all the idea is same. So you just put one that the company is looking for and have an idea of the competitors. This is what I did. So I had the data science, I had the machine learning, I had the BI tools on my resume, and so I was screened with the recruiter. That is done. So be very careful about the resume. Okay, I've done that. Next, when it comes to the hiring manager, will say, okay, do you know about my company? Do you know what we have been doing? Companies love if you talk about them. So whichever company, so I made an Excel sheet, whichever company you're applying to. Okay, first, these are the things I have put on my resume. Next, this is what I did studied about the company. Third, what questions do you have? List them out. All of these keep in an Excel sheet, and when you talk to them, you can just go through those and keep proceeding accordingly. I can share on Slack what would some good questions be like later on. And so when it came to me, the position I actually got three offers. One is in Florida, one is in California, and one is in St. Louis, where I live now. Because of some reasons, I cannot move for an year, so I took up the St. Louis one. The Florida and the California one were really good. They were paying 185K, sign on 6%, sign on bonus 6%, and 5 grand for relocation. But this St. Louis position, though it's not paying that much, it's pretty good, and it's next door. So I picked this one. Next, coming to the questions asked by the hiring manager. Was there a time when you have
Sunita, those questions will be most helpful if you can put on a Word
put
file
them.
or something.
Yes. Yeah. So basically, this is so we are all stuck up at the resume thing, right? So I'll put all of those again. This is my experience, and then so they have one pre-screening round by the recruiter. Next, you have the hiring manager. Then you have one coding round, and then you have coding oral questions. That's it. This is it. Finally, you meet the team. This is the way it goes. And as Imran suggested, I'll put all of them in a Word doc and put it on Slack. It should be helpful.
How long was the coding interview?
Coding interview, they'll give you a hacker rank, or they'll give you their DB Fiddle, they had DB Fiddle, hacker rank, or Excel online file. So they'll give you a time limit of
How
2
did you
hours.
prepare for that coding thing? Maybe that will be helpful to the participants.
Yeah, how I prepared for the coding thing is, what I do now. One thing about me is I have not had a job for 9 months now. What I did, Roshni also was talking to me yesterday, and I showed her. I built some Power BI reports, I built some Tableau, I do some SQL coding. So what I do, I prepare a database. Like I'll give in the code. Okay, create this database, insert this values, and prepared. So that has become my temporary small database, out of which I'll run the queries and I'll practice. So the questions could be anything, right? How many employees, what this, what that, all those, whatever questions we want to ask. That's how I kept practicing. That's how I did it.
Well, I think it's getting too late. Although whatever your stuff you're saying, I think it's very valuable. Would be great if you can please, if you don't mind, put something on Word document. Will really help a lot. Otherwise, maybe yes, next time I think maybe we can share
Put
them.
all of them in doc. See, one documented thing is always helpful than listening, right? So
Yes.
I'll do that. I'll put it as a Word doc for copy paste. Also, it'll be helpful. Second thing is, anybody has any questions, please feel free to ask me, and I'll be there to answer. I've gone through a lot of interviews, and after 9 months, I got this good job. So I think I should be helpful to anyone.
That will definitely be very helpful, especially if
Yeah.
you can share your.
What was different about this interview that in the previous 9 months than in the previous 9 months?
That's a very good question. That was a change in the resume. Simple.
So maybe if you can share your resume, that would be helpful
Yes,
as well.
how you put
That
in
is
the
the
resume is very
important
important.
feature then.
Yes, that's why I was saying resume, and resume. That's it.
Can you share
Everything
that? I
else-
don't know how.
yes.
I don't know if I should ask. Like,
Yeah, I will
if
share.
you feel
No,
comfortable, that might be
it's
helpful as
between
well.
us. Yeah, of course, it's between us, and it's we just
Because
want
we all
everyone
want to help
get a
each other
job,
out
right?
anyways.
Yes,
And
of
how many
course.
years of experience do you have in industry?
I transitioned from teaching to data science, but for that I took a master's in bioinformatics, and I have I extended one semester of my master's just to have this research experience, because initially my plan was to do a PhD, but then situation did not let, so I'm coming down to jobs. So I have put that research experience as 1.5 years. I have one and a
How
half
do you
years
just
of
share your
research
resume
experience.
and just put on Word document?
I will.
Guys, I have
Yes,
to
I
go.
will.
Literally, it's getting too late. But I'm really interested to hear from Sunita. I'm
I've
sure
understood
everybody
all the
are.
questions. I myself, being in that position, I know all the questions that you have and that you could possibly have. I'll document all of them. Give me a little time. Today's Sunday. I'll not have time to do, but I'll do it.
That's understandable.
Thank you
Thanks a
so
lot,
much,
Sunita.
Sunita, for
Thank you,
for sharing your
Sunita.
experience.
And
Appreciate it.
congratulations
Sure.
once again.
Thank you so much. Thank you.
Thank you very much,
Great.
Sunita.
Thank
Thank you
you.
very,
Yeah,
very
Thank you
much.
yeah.
very much.
Thank you.
Bye.
I'll put in everything. Bye. And good
Yeah.
luck to everybody. Bye.
Yeah,
You're
thank
gonna
you.
attend on
Bye.
Wednesday, right? So we'll be there. We'll continue being there. Okay.
Okay, bye everyone.
Have a good weekend, guys. Take care.
You too. Bye.
Bye.